Hello students, today we're going to apply the terms from the first lesson, and those terms would be distance, the position change that has occurred over a period of time. We'll look at a term called displacement, how far we are away from our originating spot. We're going to look at speed and velocity. So if you follow along with me and write down all of the stuff that's on the screen, then you're going to get credit. If you fail to write things down, then you're not going to receive any credit for it. So it's pretty straightforward. So the worksheet on the left-hand side is the thing that you need to have open, because I'm going to close this so that way we have a little bigger work area to have. So we have the first one. I'm going to assume the name is Janice. Janice drives her scooter 7 kilometers north. All right. And what I would do is, on your paper, it says to use graph paper, but we're not going to use graph paper. We're just going to put down our number. It says 7 kilometers north. So I'm just going to draw a vector diagram. And I'm going to put here 7 kilometers, so put 7 km. And then it says that she stops for lunch and drives 5 kilometers east. Now, to the east would be to the right. So we'll have 5 kilometers here. It says what distance, so this is part A, what distance did she travel? Well, that's pretty simple. You have 7 kilometers and 5 kilometers. All right, that's 12 kilometers total. Okay, pretty straightforward on the first part. But the second part, what is her displacement? Her displacement is going to bring up something that we are going to get to. It's called the resultant vector. The resultant vector is right here. All right, see the displacement for part B, it says how far, displacement is how far are we from our starting point. Well, we started here and we ended here, so if we did a straight line path between those 2 points, how far did we go? This is a little bit of an introduction to what a future chapter is going to be. And this is going to involve you using the Pythagorean theorem. All right, we have a right triangle that has been formed here. And all we have to do is just label our sides. We have side A, we have side B, and we have side C. So the Pythagorean theorem, if you haven't done it already, A squared plus B squared equals C squared. So we're trying to find that displacement. So I'm going to take the C, and we're going to get rid of that square by square rooting both sides. All right, so we'll plug our numbers in. We have the displacement is going to equal the square root of side A, which is 7 kilometers. And we're going to have to make sure that we square that, right? Squared, plus we have side B is 5 kilometers. Again, you have to make sure that you square that as well. We're going to put the calculator up here so that way we can see what would be the best way to put this into your calculator. So I'm going to hit the square root button. I'm going to use a parentheses. We'll go 7 squared plus 5 squared, and I'm going to close that, and it equals. So the displacement is 8.6. So put that in here. We have 8.6 kilometers. Now, here's the deal. Displacement has both magnitude and direction. And we're just looking at the introduction to this. So we have the magnitude part right now. Magnitude. The direction for this right now, we're not going to go into any trig in determining the angle of this just yet. So all we'll say for now is that this is in the northeast direction. All right, so we'll keep it simple at first. We won't do the trigonometry to figure out the angle. We'll save that for a later unit. Let's go to question 2. Question 2, it reads, if I get that out of the way, question 2 reads, Anthony walks to the pizza place for lunch. He walked east 1 kilometer. All right, so we're going to go east 1 kilometer. And then they go south 1 kilometer. So we'll have 1 kilometer here. And then they go east again 1 kilometer. So we have 1 kilometer here. Our questions are, what's the total distance that this person has walked? Well, I'm going to save you the problem of having to write this out. 3 kilometers is the distance that they've walked. But we have, what is the displacement? The displacement now, well, our starting point was right here, and our ending point was right here. So if we do a straight line, just like we had done before, that dashed line right there is my displacement. But I don't have a right triangle to solve for this to use that Pythagorean theorem, but I can create one, can't I? If we look at this, I know what the distance is because that is 1 kilometer down. And then if I just come across like this, what did I just form? I formed a right triangle. And what's the distance right here of that green vector added up together? Well, if that's a kilometer and that's a kilometer, that means that's 2 kilometers. Now we're ready to put that into the Pythagorean theorem. I'm trying to find the longest side, side C. So I'll have the square root of 1 squared, and that's kilometers, right? And I'm going to put that written in there correctly. So we're going to go plus, we have 2 kilometers squared. All right. So again, calculator time, so that way you know how to put this into your calculator correctly. We're going to go square root. We have 1 squared plus 2 squared. Close it up. And you have 2.2. We'll leave it at 2.2. So we have 2.2 kilometers. And again, we are not going to use the trig to get the direction. Instead, what we'll do is we'll just get a generic direction that this is pointing in. So this would be pointing in the southeast. Do not get used to us just using the generic directions because later on we are going to be more specific with it. So we have question 3. Question 3, on his fishing trip, Justin rides in a boat 12 kilometers south. All right, so this one right here will point south 12 kilometers. And the fish aren't biting, so they go west 4 kilometers. So right here we have 4 kilometers. What distance did they travel on this fishing trip? That's the easy part. We just went 16 kilometers for the total distance. Now, for the displacement, we go from where we put pencil and paper together first. That's our start point. And we draw a straight line, well, the dashed line, to where we ended up at. Okay, so we formed that right triangle again. So I'll make this a little bit quicker this time. So for part B, the displacement, I know that I'm trying to figure out the square root of 12 kilometers squared plus 4 kilometers squared. All right, so our calculator, we'll throw this up, and we have square root of 4 squared. Oh, we don't need to put that parentheses in there. Maybe I do. We go 4 squared plus, what was it, 12 squared? 12 squared, close it, equals, we have 12.6. So 12.6 kilometers. And for this to be displacement, I have to have a direction. So this would be to the southwest as a generic direction. We're halfway done with the top part. We go to number 4. Number 4, it says Tara goes on a camel safari in Africa. She travels 5 kilometers north. Okay, so we'll go 5 kilometers north, like this. Then 3 kilometers east. So we'll have 3 kilometers east. Then it says 1 kilometer north again. So we have just a small one right here. That's 1 kilometer north. It says what is the distance that she covered? So part A, our distance here, we have a total of 9 kilometers that she would have walked. But let's get to that question. What is the displacement? So she started here, she ended there. So we're just going to do a dashed line connecting those points. All right. We don't have a right triangle, but you can make one. So I'll come over, and then I'll come up like this, and I have my right triangle. I know that this side right here, we'll do that a little better here. There we go. So I know that that side is 3 kilometers because that's the parallel side to it. And then I know this side right here, we had the 5 here, and we have the 1 there, so that whole side is 6 kilometers here. So we'll use the Pythagorean theorem, where we'll take the square root of your 5 kilometers squared plus the 1 kilometer squared, and we will come up with, as soon as I get my calculator going, well, I guess it's going to be done a little quicker that time. So we go 5 squared plus 1 squared equals, we have 5.1 is what we'll go with. Okay, so we have 5.1 kilometers, and then we have to have a direction because every displacement has magnitude. This is the magnitude, and then we have to have a direction with it. The direction is to the northeast. We have number 5. Number 5 now says Alex goes cruising on his dirt bike. He rides 700 meters north. Okay, so we'll have 700 north and 300 east. So we'll have 300, and that was meters, east. And then 400 north. Oh, this is going to be a long one, isn't it? I should have drawn this in a different spot. Okay, we'll make a little more room. So we have 400 more north. So we'll have 400 north right here. And then we go 600. We have 600 meters west. And then 1,200 meters. Ooh. So we have something like this, because we have 7, 4, that's 1,100. So 1,200 would be just past this. So this would be 1,200 meters south. Then we have 300 meters east. So about halfway, 300 meters east. And lastly, says finally 100 meters north. All right, so we're going to have to be careful with this one right here. So I'm just going to put 100 because I'm not sure where this is going to lie. All right, so 2 things. We have part 1. What's the total distance that we have traveled? So I'm going to cheat here so that way I don't make any mistakes on this. You have 700 plus 300 plus 400 plus 600 plus 1,200 plus 300 plus 100. We have a total distance that he would have been dirt biking of 3,600 meters. Now we get to that part where we have the displacement. How far away are we from the starting position? All right, now I know looking at this that if this part right here is 600, all right, let's think this out. I know that they went to the right 300 here, and then they went back 600, and then they went back over 300. So that means that this line right here is in the same path as this right here. Okay. Then, if we're looking at our distances here, we have those two right there. We have 1100, right? That's 1100. And then you add this part right here to the mix. So that extra 100 gives you 1200 meters that would have been traveled in the y direction. Well, if they went down this way 1200 meters, what is our displacement? We don't need any math for that, because what we did is we ended up right back at the starting point. So our displacement is 0. We go to number 6. Number 6 here said Jose buys a new moped. He travels 3 kilometers south. So we'll put this in here. We'll have 3 kilometers south. And then they travel 4 kilometers to the east. All right. How far does he need to go to get back where he started? Now, that's asking what's the displacement. Okay. The displacement, how far does he have to go if we did a straight line path? What's the distance between those 2 points right there? So we use the Pythagorean theorem. Again, that's a squared plus b squared equals c squared. We're trying to find out what this side is right here. That's the displacement. So we have the square root of 3 kilometers squared plus 4 kilometers squared. All right. Calculator time. We bring this up. We go square root. We have 3 squared plus 4 squared equals, and it comes up to be 5. So Jose would be 5 kilometers away from where he started. And this says, how far does he need to go to get back? Well, if he's standing right here, if he's on his moped, he would have to go to the northwest to get back to where he is. All right, so this did not say what was his displacement. This is just saying how far does he need to go back to where he started. Okay, it is the displacement, but we're not saying that we want to know from where he was to where he ended up at. We're saying where he ended up at, how far does he have to go to get back to where he started. All right, that's the first half of your homework right here. The second half of the homework, we'll go ahead and start this right now. This is calculating speed, time, and distance. I'd really recommend, if you struggle with any type of algebra, rearranging equations, I'd really recommend that you start with this at the top of your paper. We'll have speed equals distance divided by time. All right. We are going to have to rearrange this equation. I really want this in your formula sheet, by the way. But rearranging equations may not be your strong point. So what we can do is we can use a little helpful guide like this right here. All right. We're going to see in the question, or in the formula, that distance is on top, right? So that means I'm going to put distance on top. Then I'm going to see that I have time underneath the division symbol. So I'm going to put time right there. That means the only thing that's left is the speed. And we'll see how we're going to use that throughout this. So I'll cheat and copy this so that way we can go from question to question. All right, question 1. Question 1 is a football field. So we have question 1. We're going to use the guess method for this. It says the football field is 100 meters long. So that's distance. If it takes a person 20 seconds to run it, 20 seconds is talking about time. It says, what is his speed, or what is their speed when they are running? So we're trying to figure out what the speed is, and let's leave it in meters per second. Now the first two things, I have my givens. We're not going to write this down each time. We have our givens and we have the unknown. That means we have to have an equation, a substitute, and a solve to do the full guess method, which you are expected to do. So our equation from up top, we're trying to find speed. So what I could do is I cover up the letter and I see the D, the distance is on top, the time is on the bottom. So I'll have speed equals distance over time. The substitute, I plug the numbers in for the variables, 100 meters divided by 20 seconds. So the solve then, we divide our 100 by 20 and you end up with 5 meters per second. All right, that's what you have to have in order to receive credit for this. All right, you have to have everything written down. I'm working out the problems for you. You just have to follow along and make sure that you understand what we're doing. If you don't understand what we're doing, you need to make sure that you ask. We have number 2. We have a pitcher mound in baseball is 85 meters. So I have 85 meters, that's distance. From the plate, it takes 4 seconds. 4 seconds is talking about time. It says, how fast is the pitch if that's delivered? So speed is what we're trying to figure out. We have meter per second. We'll go with our equation that we had before. Again, if we're trying to figure it out, you cover it up. Distance divided by time. The first S for my guess method, I substitute in the variables. Instead of putting D, I put it what it equals. We have 85 divided by 4 seconds. So the solve, and I don't have, let's see, I don't want to make a mistake. We have 85 divided by 4. You have 21.25. So 21.25 meter per second. All my units are in there. And I have my givens, my unknowns, equations, substitute, and solve. I did it correctly. Everything came out right. We'll go to number 3. Number 3 says if you drive 100 kilometers per hour. So I have 100 kilometers per hour. Well, that's identifying speed. And I'm driving for a time of 6 hours. Says, how far will you go? All right. We have our givens. The unknown is distance. How far are we going to travel? I'm going to put kilometers because I already see kilometers in the problem. I need a formula. This is where this little diagram is going to come in handy if you struggle trying to rearrange equations. See, we cover up the variable that we're trying to solve for, and I see speed times time. So that means I'm going to take my speed times the time. So the distance traveled, I'd have 100 kilometers per hour times 6 hours. So the distance that we're going to travel is 600 kilometers. What happens to the hours? It gets cross-canceled. And again, I do have every part of my guess method in order to receive any credit for this work. We go to number 4. Number 4, we have if you run at 12 meters per second, so 12 meter per second, that's looking at speed, for 15 minutes. 15 minutes, that's going to be our time. How far will you go? Now there's a small issue with this because I can see here that's seconds and this is minutes. We're going to have to do a conversion factor, and that's not the end of the world to do that. We are going to get the distance in meters. Question mark here. We need an equation. Distance equals. That means that we're going to multiply those two variables together. So distance equals, you have 12 meter per second times 15 minutes. But we need to have a conversion factor. We have to get rid of minutes, don't we? We want to have minutes. 1 minute, let me put in minute. 1 minute equals 60 seconds. So I need to get rid of this minute right here. I see minute in the conversion factor. So that means I'm going to put it down here in the bottom. And that means the rest of that conversion factor, the 60 seconds, is going to go up top. See, what we have formed here is a bookshelf right here, right like this. Okay? So the last part is the solve. So I'm not going to make an effort at trying to do that in my head. We're going to punch it in. So we have 12 times 15 times 60, 10,800. We have 10,800 meters is what we're going to have. All right. We go to number 5. Number 5 says every summer I drive to Pennsylvania, it is 895 kilometers. So that's going to be a distance. If I average 100 kilometers per hour, so I have 100 kilometers per hour, that's speed. How much time is it going to take for me to get there? So I'm going to put time question mark. Now since I see hours right here, let's use our unit of hours for the time. I need a formula. If I cover up the variable I'm trying to find, I see that time is going to be distance divided by speed. So I can plug in the numbers. You have 895 kilometers times, and our velocity for this was 100 kilometers per hour. All right, we have a small issue here. Oh, the small issue is I plugged it in wrong. So let's put this in right. We have our distance, and we're going to go divided by. There we go. See, that's why we want to put down all of our work. So we'll have divided by 100 kilometers per hour. And when we divide that out, you should come up with a time of 8.95 hours is what it's going to take for you to travel that distance. Okay? We go to number 6. Number 6, a bullet travels at 850 meters per second. That's a speed. How long will it take? So we're trying to figure out the time. I'm going to put seconds in here because I already see the unit seconds. For that bullet to go a distance of 1 kilometer. Now that's distance. Okay. So looking at our equation, this time hopefully I get it right. For our time, we're going to have distance divided by speed, and we'll plug in those variables now. I know the distance is 1 kilometer, and I know the velocity of this bullet is 850 meters per second. Now, there is a small problem that we're going to face here before we can get started. I see kilometer and I see meter, and those two things don't match up. So what I have to do is I have to add in here a conversion factor. 1 kilometer is the equivalent of 1,000 meters. So I'm trying to cancel out the kilometer. I find kilometer right here. So that means when I cross cancel this, it's got to go on the bottom. And then the rest of this has to go on the top. All right, so essentially what I end up with is I have 1,000 divided by 850, and I get let's round it off, 1.2 So we'll have our answer as 1.2 seconds. It's not going to take very long because the bullet travels at a high rate of speed. You only have 1 kilometer that's going to be traveling. It's not going to take long to get through there. We have number 7. Number 7, every winter I fly home to Chicago. It takes 3 hours. So we have 3 hours. That's looking at time. What is my average speed? So we're trying to figure out speed, and they do not give us a distance. So let's do this. I'm going to cheat here for a second, and I'm going to say that we're going to go from Upper Sandusky to Chicago, and we'll see what our distance is. So Upper Sandusky to Chicago. It is 270 miles. All right, so that's the number that we're going to use. So our distance from Upper Sandusky to Chicago is 270 miles. And it doesn't ask us, it doesn't ask us in terms of units. It doesn't say kilometers, so we can just do this. So we'll say miles per hour is what we're going to have. So speed equals, we know that speed is distance divided by time. So speed is going to be 270 miles in 3 hours. So our speed here is going to be 90 miles per hour. All right, so somebody's breaking the speed limit here. All right, but that's how we would figure it out. Now, that value would change if you use different distances, of course. We have number 8. Number 8, the fastest train in the world travels at 500 kilometers per hour. How far will it go in a time of 3 hours? So that's our time. So we want to figure out what the distance is going to be. So we use a little formula guide here, trying to find distance. So I'm going to cover that up. The distance in kilometers, I would need the equation speed times time. We'll plug in the variables. Our speed, 500 kilometers per hour times 3 hours. So the distance it's going to travel, 3 times 5, 15, and you plug those other zeros in there. We have 1,500 kilometers is what it's going to travel. We have one more question. We have number 9, and our homework is all done. How long will it take? All right. How long? We're trying to figure out what the time is here. How long will it take light moving at the speed of light? All right. So the speed of light is 3 times 10 to the 6th here. So we have 300,000 kilometers per second. Okay, 3 times 10 to the 6th kilometers per second to reach us from the sun. The sun is a distance of 15 million kilometers from the Earth. Okay, so if we're trying to figure out how many seconds it's going to take, because it doesn't say anything about units, so we'll just keep it as that. So our time here, let's again cheat and use our little diagram. So we're trying to find the time, so I'm just going to cover it up. That means that I'm going to take the distance divided by the speed. I can plug in my numbers. I have the 15 million kilometers divided by the speed, that 300,000 kilometers per second. So we have 15 divided by 3 is 5, and then we have 5 zeros that we can get rid of right here. So we have 50 seconds is what it's going to take. All right, I'm just going to double check. I hate just doing this without double checking myself. So if we have 15 million divided by 300, I have my equals 50. Yeah, I just want to double check. It's always best to double check instead of putting something up that's wrong. All right, so you have all of the work. You have all of the questions that followed that guess method. Pretty simple. What you need to do is take a picture after you have put your name at the top of the paper. You put your name at the top of the paper, you take a picture of it, you submit it to Schoology. It's an easy A. All right, if you have questions or concerns, make sure that you ask. If not, we'll move on to the next subject. All right, take care.